Hi everyone, this is Cody Jackson for Codemom, and this time we are talking about namespaces and modules within Python. You've seen it before, you're probably going to see it a lot more. Just letting anybody know who's interested, the examples that we're talking about in this video series is coming from the Learn Programming in Python book. If you want some more additional advanced stuff, take a look at the Secret Recipes with Python Ninja. I've written both of those, so if you have any questions about what the content is in there, you can always hit me up in the comments and ask me questions about what's in the books and why I did things a certain way. Namespaces. Namespaces, also known as scope, is a hierarchy of how object names are looked up within Python. The segregation of the different namespaces allows the same variable name to be used in different locations. While that's not recommended, it does allow it to be possible. If you're using a development environment that has a linter is just a program that takes a look at your code and checks it for best practices for that particular language. Do you have the correct empty lines between functions? Do you have the correct number of spaces between a pound sign and the rest of the comment? Things like that. One of the things that a linter is going to do is tell you, are you shadowing a variable name from an outer scope? And if you don't have namespaces, everything's just going to be in basically a global environment, and you can cause program crashes or get incorrect data because you're referencing a previously named variable and the computer's not going to know which one you're discussing. So from a big picture perspective, the namespace hierarchy first looks within a local container. So say a method within a class. If it can't find a definition there, it's going to look within the enclosing container, so the class that holds that local method. If it can't find it within that enclosing container, then it's going to see, is it defined globally as a global variable? If it can't find a global variable, then it's going to take a look at imported modules, and those can be third-party, or they can be built into the Python language. If it can't find it from an imported language, then it's going to look at the built-in modules that are commonly allowed to any Python program, regardless of whether they are directly imported or not. If it can't find it anywhere, then Python is just going to generate an error, and you're going to have to deal with that. Looking at it from a different perspective, from an actual code-based perspective, in this instance, we have a if statement block that is defined as our local container. So if there's something that is defined within, I should say, if there is something that is used within the if block that has not been defined yet, first Python is going to look within the local container to see if it's defined somewhere within there. So it's somewhere within the if block. If not, it's going to look at the enclosing container, which in this case is going to be a method, and see, is it defined there? If it can't find it there, then it's going to see, is it a global variable defined within that enclosing container, which would be a class. So would we have class, my class, and then a variable defined here before the method. If Python can't find the object within any of those enclosing containers, then it's going to take a look and see, is it a program-wide global variable? If it can't find it there, then it's going to look for imported libraries. If it can't find it in an imported library, then it's going to look at one of the built-in libraries that's universally available. If it can't find it there, at that point, it's going to throw an error at you. So in this case, I have defined var1 is equal to 2. This is a global variable. If var1 is equal to 2, var2 is equal to 2. So while this would be an instance of a enclosing container or a local container, because it's not within anything else, it's also a global variable too. So it's a enclosed and global. Doesn't really make sense probably at this time. It's one of those instances where you just have to believe and go with it. If you do have an error in how you're expecting this, your linter within your IDE, it will give you notification of that. So anyways, if we print the unmodified var2 variable, then we see that it is 0, which we've already defined it as. Next, we define a function. Here we have a local variable, var3. We have another local variable, but in this case, it has the exact same variable name as our global variable, var1. So it's going to shadow it, and you'll see what difference that has as we go forward. We call var2 expressly as a global. That means that this is not defined as a local variable. This reference to var2 is actually coming out and pulling this global variable here. So effectively what we're doing is linking this name here to this name here. So when we reassign 60 to var2 to overwrite 0, we are actually overriding this variable here and not a local variable. And then we go ahead and we print these out. You'll see var1 is set to 46. So indeed, it's looking locally within this function first. And because it found that object, it doesn't care what this global variable is defined as. var2, because we expressly said use the global version of this variable, it goes ahead and it overwrites it with 60. And we'll confirm that in a second. And then var3 was just defined locally, and so that's what it is. If we look outside of the function and we just call these variables directly without being predefined within this function, you'll see what the values are. So var1, which was defined as a global variable but not used as a global variable within the function, is still set to the global value of 2. 60 for var2 was defined internally but put into the global variable, and therefore our global variable value of var2 is now 60. So that has been overwritten. var3, because it was never defined outside of this function, you get an error telling you that it is not defined. So basically the Python interpreter says, I'm looking at the program, I can't see inside this function because you haven't called it expressly as you did here in line 8. Therefore, I can't see what's inside the function. I can see var1, I can see var2, var3 doesn't exist. So you need to redefine it and tell me what var3 is. So I hope that kind of gives you an idea of what I'm talking about in terms of the namespaces, the scopes, how it starts from the inside and looks outwards and continues looking until it gives you an error. So I talked about importing modules, and I even gave you an example of the importing math previously when we looked up here. We were importing a a library within to this program. So modules, packages, and libraries are commonly used synonymously when you're talking about these things. There are some specific differences between them. The main one that you need to care about is that a package is a module or a library, but there is an empty $_init.py file that allows Python to easily locate that module. And we'll get into the details of that much later. It's not relevant right now. Just be aware, for this point in time, modules, packages, and libraries, all basically the same thing, which is a self-contained Python program which may or may not reference other modules, but they're commonly used to provide additional functionality to other programs. So, for example, that math library that we imported, by itself, it doesn't do anything. I mean, you can run some little test functions and stuff like that, but really what it's doing is providing additional functionality for your program. So if you need to run trigonometry formulas, you can call the math library and do those without having to hand code those formulas for you. PyPy.org is the official repository for Python packages that are not built into the Python interpreter. So this would be like your third-party packages and stuff like that. Often what happens is somebody will improve on the built-in tools that Python provides, making life a lot easier for you. So while you can use a built-in package, it might be easier to go ahead and get a third-party package from PyPy. There's a couple of different ways to import modules. The most common is to call import library or import library as name. So we saw that we had import math. What you may also see, especially if you're doing data science, is a lot of import numpy as np. So you don't always have to type numpy every time. By importing it this way, you keep those namespaces separate. So you are importing that namespace. So if I import math, I get the math namespace. And so all of the data that's within that math library is held within that math namespace. There's no potential of overriding it with my local code. From library, import a specific module, which usually means, like, for example, from math, import square root or import cosine. That would be an example of taking a certain part of a library and importing that only into your program. The reason to do that is it limits the amount of overhead that you're not going to be using, so you don't need to deal about the memory space for it. Again, this also maintains that namespace for that particular module that you've imported. So if we imported the cosine portion of the math library, then it would be math.cosine to access it. So again, it's still not part of your personal program's namespace. If you want to put everything that you're importing into your own namespace so you don't have to specify where it's coming from, then you can do from your library import star. So if you wanted to import everything from the math library, your option is to import math, which keeps the namespace, or import math, or sorry, from math import star, which will again import everything, but it does not keep that math namespace. You can call cosine directly and not have to worry about math.cosine. The problem is then you start running into potential shadowing errors because you can have the same name and not know it. So I touched a little bit on this in the last example, .nomenclature. Basically what happens is you have to expressly state, using dots between the words, where the path is to find the module that you want to use. So I talked about in the hierarchy of the namespaces how imported modules will be looked at, and then the always available built-in modules that Python provides. And so you need to specify exactly where Python is supposed to find the function for you. So in the example down at the bottom, you see that we have import math, and we've defined locally a square root calculation for determining square roots, but you can also take the math.square root from the import, and using .nomenclature, math.square root, we are expressly telling Python, use the square root calculation from math and don't use our personally defined square root. If we did not have math dot, then Python, going from inner to outer, the first thing that's going to find is our locally defined square root calculation and use that rather than the imported math calculation. So again, I hope that makes sense. All right, so hopefully this example will explain better what all of that verbiage is that we had previously. So from the random library, we import randint. So this basically just generates a random integer from whatever values you provided. In this case, randint, we are saying go from 0 to 100, and it gives us 46. Now, because we have imported randint into our namespace, it already knows that randint is part of random. If we want to call randrange, we haven't imported that, and so it's not defined locally, and there's no import that calls it, and there's no built-in that provides it automatically, and so randrange comes back as an error saying that it's not defined. And so if we try to just say, all right, using .nomenclature, give me random.randrange, again, we didn't import the entire random library, so that's still an undefined name. If we go ahead and we import random, the entire random library, we don't have to import randrange separately. We can call random.randrange, and it knows exactly where to look for it. So, thinking back, I may have misspoke about the from library import module. I think I said that you still have to use random.randint. That is incorrect if I did say that. You can see here that because it is imported, it is part of this namespace. So randint doesn't have to look any further. It's part of the local namespace. Whereas if you're importing an entire library, then you do have to use a .nomenclature to specify that. So I want to show how that name shadowing can cause problems if you do an import star. So we went ahead and we did from random import star. So import everything from the random library. Now this is where you get problems of stepping on previously defined values. If I say randrange is now equal to a text string spam, and then I call randrange, then it returns spam. So I don't get a random number or anything like that. If I call randint, which we haven't touched yet, it was imported expressly up here, but that's it. It's still part of the imported namespace, but at this time, instead of generating an error, it just says, hey, here's your random value at this particular memory address. Because we didn't call it, with the where the range is of the integers that we want back, but it's still telling us that this is a legit call to the random library, whereas our randrange was a call to a locally defined variable and not to the imported library. So I hope that makes it a little bit more clear. So I had mentioned that primarily, modules are set up to import their contents to other libraries for use, but you can sometimes use them directly for special purposes or something along those lines. Generally speaking, modules, packages, and things like that are not meant to be used by themselves. They're supposed to be imported into another program to provide additional functionality. But there is a way to provide a limited amount of functionality for specific reasons. If you want to provide some testing code to confirm that it works correctly, if you want to provide some limited functionality just to play with it without importing it into another program, for example, I think we tested a HTTP server, and you just do that just to confirm that the server functionality is working and you haven't broken anything. Also, you must use the if name double equals main. That's required for Windows programs, otherwise they have a tendency to crash. Caveat, I don't know if this is still true. This is how it was years ago. It may have changed with the newest versions of Windows, but as of Windows 7, and even prior to that, you had to have it in there. Don't freak out about this right here. We'll take a look at a example of code and see what I'm talking about. But just say that this portion has to be within your code to make it locally executable and not import only. If you have this line and you import that module, everything that is below the line is not imported. So only the classes, the functions, variables, all of that stuff will be imported over, but any processing code logic that you have, for example, testing instances, will not be ported over. If you call the program directly, that means that the name or namespace is going to be defined as main. This program that you run is always the main namespace. If you import a module, then it becomes the namespace of the program that's running. So in this case, if I'm importing a module, then its namespace is no longer going to be main because it's not running. It's going to be the name of the program that's being ran. That's not entirely accurate, but for these purposes, it's sufficient. So to run the test code, then you would have to run your module by itself. You cannot import it. If you want to run that test code or whatever the portion is below the if name main, then you can call it using Python-m and then the module name, and then it knows to import it as a main namespace and not imported into another program. I think I'm not making sense. So let's look at an example. So I'm not sure if I've shown this one before. This is one of the very first programs that I ever wrote when I was learning Python. And this is basically just a dice roll simulator that you can use for role-playing games, video games, anything really. So in this case, we are importing the random library. We define a function that basically generates a random value between whatever you specify it as. And so we've got a D6 roll, a D10, a D100. So all of these different types of values that you can have. And you can add more if you need weird values, like a true false or something like that if you need a coin flip. Another function that allows you to add multiple dice rolls together, so it's not just a single dice. And then down here, as I said, this is our if name equals main line. So if the namespace of this program is called main, if this is the main program that's running, then go ahead and run the code below this. If the namespace is not main, meaning it's been imported into something else, then it's only going to allow this data up here to be available. So it's not going to run the test code. If we go ahead and we call this program as is, then it goes ahead and it runs the test code and just gives us a variety of dice rolls just to show that the program is working. And you can see every time we run it, the numbers change. So again, this is good confirmation to show that the program is generating random numbers and it's not just something that is stuck in memory. Now, one thing to note, I had talked about using the -m argument when you're calling it to call the module function. So if you change to the directory where it's located and you call the program Dice Roll Simulator with the -m flag, you do not have to call the .py anymore. The -m tells Python that this is a module that's normally imported, but in this case you want to run it as the main namespace, and so again it will call the code that is below the if name equals main portion, and so in this case it will run the tests again. So I hope that makes sense. If not, please leave a note in the comments and I will see about improving on my discussion of this. So that's it for this video. We talked about the concept of namespaces or scope and the hierarchy of the different lookups that are being performed on the objects. We talked about importing modules to provide more functionality. We talked about .nomenclature to expressly identify where a object is coming from so that you don't accidentally shadow it. And we talked about using the if name equals main to provide executable code for a module that is normally imported and not executed by itself. So next time we're going to look at conditional statements, the if-else portions of logic, which is very, very common in addition to loops to make programs work correctly. So that's it for now. I hope you enjoyed this. If you have any questions or comments, please let us know. Until next time, continue having fun and continue learning. Thanks. Bye.